Oh my goodness.
Okay. Particle motion part 2. We did part 1 at some point. I don't remember when at this point, but it might have even been via video and I wasn't here because I've done some of these via video. But okay, so particle motion. Now, I had written up here, sorry, kind of sloppy. Could you read it?
Yes.
But I was trying to write it quickly this morning. As we talk about particle motion, we're talking about acceleration, velocity, position, our derivative integral relationships there, right? Okay, so the side note I had written down here that's going to help us as we talk about this, the definite integral of the velocity function. Okay, so definite integral of the velocity function of a particle moving along the x-axis represents the algebraic sum of the left and right distances traveled. Because when you travel left, it's going to be represented as a negative. When you travel right, it's going to be represented as a positive. Okay, so that's kind of the idea. We're going to use that as we go into this first example. The velocity function for a particle moving along the x-axis is v of t. The following is given. So first of all, let's make sure we can read these numbers. The integral from 1 to 2 of velocity is -7. The integral from 2 to 3 of v of t is 3. The integral from 3 to 4 is -2. And the integral from, I assume that's supposed to be 4 to 5? Yes, is 6. Okay. Now, given that information, how much does the position of the particle change over the interval from 1 to 5? So, pretty much. Because, okay, so what's it going to do? So from the time 1 to 2, what's it do from the time 1 to 2? It goes left 7, right? It's a -7, so it's going left 7. And then the interval from 2 to 3, what's it doing? It's a +3, so then you're going right 3. Then the interval from 3 to 4, you're going to go left 2. And the interval from 4 to 5, you're going to go right 6. Well, if you go left 7, back right 3 puts me at -4. Left 2 is going to take me back to -6. Right 6 takes me to 0. And so this is what I would call, what if I say net change? Maybe makes you think econ, I don't know, but okay. The net change of 0. In other words, if we're asking, this is asking how much the position of the particle changes. It starts at one place, it moves left and right some, but then it ends at the same place. And that's kind of what we're asking here. B. If the particle is at x equals 7 when t equals 2, what is the position of the particle when t equals 4? So at x equals 7, when t equals 2, to t equals 4. So what's the interval we're doing this over? This is over the interval from 2 to 4. Where do we start? We're starting at a position of 7. What do we do from that position of 7? What's the first thing I'm going to do?
Well, we know that that's at t equals 2.
Right, that's at t equals 2. So we're going to start here. Basically, we need to go from 2 to 4, right? So from 7, the first thing we're going to do is we're going to go right 3. Because from time 2 to 3, we're going to go right 3. Is that it? No, because then we need to go all the way to time 4. And from time 3 to 4, we're going to go left 2. So if you start at position 7, you go right 3, but then you backtrack left 2, what position do we end up at? 7 plus 3 is 10, minus 2 is 8. And yes, it is elementary adding and subtracting. Well, I guess we throw negatives in, so 6th grade.
We did learn negatives in 6th grade.
I know, but look back on it, like,
Technically,
we didn't do multiplication to like 4th grade. That's why.
Long division wasn't until like 5th or 6th.
4th and 5th, I would have said for long division.
Yeah.
I think 4th grade is when it's introduced. But,
we didn't do any algebra until like, what was it, 8th, 7th grade pre-algebra? 8th
Probably.
grade for like a normal level
Yeah.
student.
Yeah.
That's crazy.
And now it's all old hat, right? Only negatives were old hat for all high school students. Okay. Unfortunately, they're not, but for you guys, I trust they are. Okay, example 2. A particle moves along the x-axis so that its position function is x of t equals. And can you figure out the powers? It's 2t to the 3rd minus 9t to the 2nd plus 12t plus 1. I know, the copying job is horrible here, but okay. What are the positions of the particle at 0 and at 3?
Seems like we need to look up those numbers in the equation.
Yeah. They give us a position function. They ask us the position at certain times. So, dare I say plug and chug? Don't make it fancier than what it is here. They want to know the position at time 0. We're going to find x of 0. They want to know the position at time 3. Whoops. We're going to find x of 3, not x equals 3. X of 3. What happens when we find x of 0? We get 1. We get the easy one out of the way, right? Okay. What about 3? 27 times 2 is 54 minus 81 plus 36 plus 1. My brain lost it.
Yeah.
I mean, I was just doing the plugging in there of, okay, if I plug 3 in, I can do the 54 minus 81 plus 36 plus 1. Okay, I can go with that. Okay. So, part B. What is the total distance the particle travels between t equals 0 and t equals 3? What?
Do we need an integral?
Not an integral, actually, at this point.
Is it just the distance? Like the
Because
square
we could
root
say-
of x, whatever it was.
So we could say it went like, the net change was 9, but we don't know if that's the total distance.
Right, and that's the catch, is that you have to notice they're asking for total distance. The net change, you know, how much does if we go back to the original question A from the previous one, how much does the position of the article change over the interval? It has a change because it starts at 1 and ends at 10, but what's it do in between? Okay, so what we need to figure out is at what points might it stop and turn around and go the other way?
0 of the velocity.
When does your velocity equal 0? Are we following this now? So what we need to figure out is velocity, and when does velocity equal 0, because those are going to be the points where my particle will change direction. Okay? So, how do we find velocity?
No, derivative.
We are finding x prime of t, which is going to be v of t. So what is the derivative of the position?
6t squared minus 18t equals 2.
Okay, I can go with that. 6t squared minus 18t plus 12. Officially, we need to set the velocity equal to 0 to make this happen. Now, as I set this velocity equal to 0, what do you notice about all three pieces?
6 divides out.
Get that 6 out of there. And I guess technically I just kind of factored it out for right now. But here's the deal. Now that I have it equal to 0, can I divide that 6 away and not even worry about it? I can't. I can't divide it out of an expression, but I can divide it out of an equation where I can divide both sides. So 6 isn't going to matter. What do you know about t cubed minus 3t plus 2? T squared is t and t. I heard negative 2 and negative 1. If you set both pieces equal to 0, then we find t to be 2 and 1.
So we have to plug both those into the position.
Right. In other words, right now we know, so we know the position at 0 is 1. So at time 0, my position is 1. What about at time 1 and time 2? And I'm going off the screen here, but normally it fits better on my paper. The BenQ, when I don't blow it up all the way, it doesn't fit quite the same. And then we also know the position at time 3. Yes, position at time 3 is 10. So we need to know our positions at time 1 and at time 2. Because those are the points when my particle turns around. What is my position at time 1? Okay. X of 1 is positive 6. And we need a position at time 2. I got 5. Okay, guys. So, total distance traveled. Left and right aren't going to cancel each other out here. Total distance traveled. From time 1 to time 2, how far did my particle travel? We traveled how many units? From 1 to 6 is a total of 5 units, yes? From time 1 to time 2, how far did my particle travel? Okay, backwards a unit, but that is still a distance of 1. So it traveled 1 unit. I don't want to think negative because that's going to give me net. I want to think total travel. And how far did my particle travel from time 2 to time 3? It traveled a distance of 5. So what do we know? 5 plus 1 plus 5 is 11 units. Notice, if we make that 1 negative here, that takes us back to the answer of 9, doesn't it? Because you'd go 5, minus 1 is 4, plus 5. So, watch the question. Do they want to know the position? Do they want to know how much, the change of the position? Or do they want to know the total distance traveled? Okay, example 3, when you guys are ready. The acceleration of a particle moving on the x-axis is a of t equals 4 pi cosine t. If the velocity is 1 at t equals 0, what is the average velocity of the particle over the interval from 0 to pi? Okay, are your brains ready? So let's see, they give me acceleration. If the velocity is 1 at t equals 0, what does that tell me? Okay, I was going to say it says v of 0 equals 1, but I see where you're saying that. Do me a favor, don't reverse the 0 and 1. That happened a little bit on the test yesterday. Some of you guys got C values of 15 instead of 3 or something because, I don't know, there's 2 or 3 of you that reversed it. Okay, so velocity is given. What are they asking me for? Average velocity of the particle over the interval 0 to pi. Okay. Well, thoughts on where to start?
Well, we use an acceleration, so we need the velocity, so we're going to need the interval of that value.
We are given that the acceleration is 4 pi cosine t. So we are given acceleration. We know the velocity is the integral of acceleration. So I agree to do velocity here. We're going to do the integral of 4 pi cosine t dt. Okay. What is, my brain says 4 pi is a constant. So 4 pi, I just put it down. What is the integral of cosine of t? Sine of t. So 4 pi sine t plus a constant. We're going to be official here, say plus c. And this is one where I would be careful and make sure you plug the values in and not just assume. Because I know Ross said, okay, so c is going to be 1 when we had that v of 0 equals 1. Don't just assume because we're messing with trig functions here. If you put 0 in for x's, yeah, those x's are gone. When you put 0 into a trig function, beware. It's kind of like when you raise something to the power of 0, right? Beware, it's not just going to be gone. So, not saying this one's not, but.
Yeah, I already worked it through.
Yeah.
I knew that it was.
Okay. So it's helping us find our C value. So yeah. Officially, V of 0 equals 4 pi sine of 0 plus C equals 1. What do we know about sine of 0?
0.
Sine of 0 is 0, isn't it? So since sine of 0 is 0, then we do indeed find that C is 1. So our velocity function is indeed 4 pi sine t plus 1. Now, we're not done. That's just our velocity function, right? they asked us to find average velocity over the interval 0 to pi.
Average velocity, you say?
What's the key word there? Average. I taught this via video, didn't I? Okay, but I said you will randomly see average pop up in calc problems. And often then, when they are looking for an average value, well, I guess we'll do it that way. There we go. Average velocity, how do I have to set this up?
I forget, but there's the formula for it, right?
There's a formula for it. What fraction goes out front?
Is it
1 over b minus a? What are my b and a?
0 to pi?
Yeah, right here, the ends of my interval are a and b. So 1 over b minus a is going to be 1 over pi minus 0 times the integral from a to b, so 0 to pi, of our velocity function. And our velocity function is 4 pi sine t plus 1 dt. This is the first time we've used it since that lesson, though. I mean, other than homework questions, right?
I didn't remember doing it on homework. So.
Well, is this what I taught on Friday? Was this lesson 89?
It was, yeah, I want to say.
So it's the last lesson I taught.
Yeah.
Which
It's
means
just we got tested.
you had a test, yeah. This is lesson.
Oh, I see it now.
I don't know, because it was definitely
I'm
on.
looking at it.
I remember that this is when I
Never
taught
mind, it
via
wasn't on
video.
homework. Never mind.
Okay, so 1 over pi minus 0 is going to be 1 over pi. In all honesty, what I would say, dang it. Okay, what I would say here is that the 4 pi you can pull out front, yes. So I've got the 1 over pi out front. I've got the 4 pi I'm going to go ahead and pull out front. What's the integral of, oh, whoa. I'm teaching wrong. Sorry, being blunt here. Why am I teaching wrong? Why can I not pull that 4 pi out front?
Because it's
I forgot about that plus 1. That's the honest truth. I just forgot.
I was like, wow, the pies cancel.
I know, I was all excited too. Okay, sorry guys. I just glanced up here, I saw the integral of 4 pi sine t, and I was like, oh, we can just put that 4 pi out front. But we can't because it's part of half of the integral, not all of it. So, okay, what is the integral of 4 pi sine t? Or what's the integral of sine t? Negative cosine t. So if we put the 4 pi, it's negative 4 pi cosine t. Plus, what's the integral of 1? I'm going to say t in this set. Evaluated from 0 to pi. Yes, always remember the integral of a 1 is the variable. Okay, that was a mistake yesterday somewhere. Okay, guys, the 1 over pi I'm going to keep out front. I am going to scoot over so I have some room here. First, I am plugging in pi. So negative 4 pi cosine of pi plus pi minus, and now I'm going to plug in negative 4 pi cosine of 0 plus 0.
Okay.
So 1 over pi is still out front. Okay, what is the cosine of pi?
Negative 1?
Negative 1.
Yes.
So negative 4 pi times negative 1 plus pi, if you will. Well, negative 4 pi times negative 1 is going to be 4 pi, plus 1 pi is going to be 5 pi. I'll write that down in a moment over here. Here. So I'm going to have my 1 over pi out front, my 5 pi. Okay, what about this? Negative 4 pi, gosh darn it, struggling. What's the cosine of 0? 1 plus 0. So negative 4 pi times 1 is going to be negative 4 pi. It's really going to be minus negative 4 pi, which is going to make it 5 pi minus negative 4 pi is going to be 9 pi times 1 over pi, just 9.
The pi's do cancel.
The pi's do cancel. We just had to get there, right? 1 over pi times 9 pi is 9. 9 what?
Units per second.
This is velocity, so it's a distance per time. In this case, yeah, we weren't given, so. Units per second. Okay. Definitely talked too much at the beginning of the class today. Okay, example 4. The velocity function for a particle moving along the x-axis is given by v of t equals 2 pi cosine pi t. For what values of 0 and t is the particle stationary?
So we need to find the zeros.
When is a particle stationary? When its velocity is 0. So we are going to take the velocity and set it equal to 0. So this does say 2 pi cosine of pi t, and we're going to set it equal to 0. Now, if we have 2 pi cosine of pi t,
We can split that, right, into 2 pi and cosine of pi t.
you don't want to split it because 2 pi is just a number. 2 pi is not a variable. So if 2 pi is just a number, how do we get rid of that number?
Just divide it.
You divide it, right? If you divide by 2 pi on the left, it cancels. If you divide by 2 pi on the right, 0 divided by 2 pi is 0. So really the equation we're thinking about is cosine of pi t equals 0. Now, this takes us back to pre-cal. We've probably done it here in calculus at some point, but
We have to do the negative, right, not inverse, but like the cosine inverse of that. Or no?
I guess you could think of it that way, although we don't want to restrict the range there. This is where I kind of say, okay, in general, where does cosine equal 0? Now, the trick is, though, that it's not just cosine of t, it's cosine of pi t. So, when does cosine equal 0?
It would be at
Pi
pi over 2 and
At pi over 2. Where else?
then the other angle down there. 3 pi over 2.
The other angle down there. Got
I
it.
had to think, I was thinking of the inner circle and then it's like the straight line. I had to think like, okay.
And here's my brain working. My brain says, my brain does that.
Yeah,
You know, and both are good, right? You were taught unit circle first, but both are good. I think that way, and I say, okay. Now, officially, what would be the next one? If there's pi over 2, 3 pi over 2, when's the next time it equals 0?
Yeah, just add
Someone just said it.
2 pi to that, right?
5 pi over 2? Because technically, this keeps going on and on, doesn't it? Now, what we have to notice is we have to make sure we get all the right values inside our interval. Okay? So, now, what is it that equals pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth? Well, normally, we could, if it was just t here, these would be our answers.
But it's pi t.
But it's pi t. So this is where I say set pi t equal to all these pieces. Does that sound familiar? We did that in pre-calc. I think, no, maybe we did it in calc. We did it in calc. That's not a pre-calc thing, that's a calc thing. Solve for t. What's going to happen if you solve for t?
The pi's are just going to cancel.
Yeah. If you divide by pi, or you multiply by 1 over pi, the pi's are canceling. My first time is 1/2. My second time is 3/2. My third time is 5/2. Technically, my next time would be 7/2. But what answers matter here?
What between 2 and 2?
1/2 is a valid answer. 3/2 is a valid answer. Do I need 5/2? No. But that was my point of, you have to figure out, could we have needed to go farther? We could have, depending on what interval they gave us. Which is why I didn't have you just stop once around the unit circle. I wanted you to consider all the options. Okay. One more example. What is the total distance traveled to the left by the particle in example 4 between t equals 0 and t equal 2? After you've all just gotten your books flipped over so nicely. Which was example 4? The one we just did, yes? Okay. So keep that in mind that that's the one we just did. We want total distance traveled to the left from time 0 to 2. Okay. If you recall, our function that we were using was v of t equals, was it 2 pi? Yeah. 2 pi cosine pi t.
So something about find over values and negative.
Where are values negative?
When it goes to the left.
When we look on a graph, when are values negative?
Under the x-axis.
Under the x-axis, right?
So in between zeros or halves.
So if you think about the graph of cosine, yes? The graph of cosine was doing this, right? And this was from time 0 to 2, correct? Because if you go back and think about here at pi over 2, it was 1/2, 3 pi over 2, you know, we can use that. So this was 0. This was our 1/2. This was our 3/2. When are we going to be traveling left?
In between zero. So in between 1/2 and 2.
Right here. And I guess I didn't talk about the 2. We could have graphed this on the calculator, okay? But I'm trying to, because this is the graph of v of t. But the idea here is that what is underneath, because this is the graph of v of t, what is underneath the axis is your negative velocity. And so negative velocity is going to be traveling left, of course.
Okay, so now we do an integral, right?
If we're asking for the total distance traveled to the left, we need the integral from what to what?
1/2 to 3/2.
Only where it's negative. So 1/2 to 3/2. And I made my graph too big, so I don't have room to do. You guys have a whole paper to just go down the paper. I don't. So I'm going to do it over here. The integral from 1/2 to 3/2 of 2 pi cosine pi t dt. Can I pull the 2 pi out this time?
Yeah.
Okay, this time I'm okay, right? This time I'm not leading you astray. Hey, when I make mistakes, I lead you guys astray. So 2 pi, I'm not even going to worry about that. What is the integral of cosine of something?
The sine of that something
Sine of that something.
times dt, right?
Not times dt, because we're going to evaluate. But
Yeah.
1 over.
we have to compensate for, if we were doing the derivative,
So we have to do 1.
we'd have to do the derivative of pi t, which would be pi, right? How do you compensate for a pi when we're doing an integral?
Divide by pi.
I'm going to say multiply by 1 over pi, but yes. Okay, it's kind of like if that had been a 2t. When we do the derivative, we do times 2. When we integrate, we have to compensate for that and do times 1/2 or divide by 2. So 2 pi times 1 over pi sine pi t evaluated from 1/2 to 3/2. Now, I don't know about you guys, but we've already got the 2 pi out front. Besides the 2 pi out front, I'm going to keep the 1 over pi out front because that's going to be nice, isn't it? Sine of pi t is going to be sine of 3 pi over 2 minus sine of 1 pi over 2. So I'm plugging in my 3/2 and my 1/2. If you haven't already, 2 pi times 1 over pi is just going to be 2. Sine of 3 pi over 2. There's my, this is what I go to, but yes. So sine of 3 pi over 2 is down here, -1 minus sine of pi over 2, 1. -1 minus 1, -2 times 2, -4.
Pies cancel again.
You're liking these pies canceling.
I love it when they cancel. I hate them.
Okay.
I hate leaving them the answer.
So, does it make sense this came up negative?
Yeah, we're going to the left.
Well, we're going to the left and we integrated something underneath the axis, right? So negative sign area, negative sign indicates the area is below the x-axis, and we moved 4 left then. Okay? I don't know if you want that information or not, but negative sign indicates area is below the x-axis, which again, I'd be shocked if we didn't it. So I think I'm going to, whoops. What is my eraser doing here? Okay. I'm trying to say particle traveled left 4 units. Okay. That -4 indicates left 4.
it doesn't matter what it says, it's right.
No, it just means that if the total distance was left for, is why that's the negative, so. Okay, I'm writing your few changes here. Okay, 22 through 25 are going to be 5 through 8 from 86. I can't remember if they were problems I just didn't want you guys doing or if they came from 86 originally, but, and then 16 is going to be 23 from 87.